Hi everybody. This is the rotate image algorithm from lead code, and I'm going to try to solve it. So you are given an n, x, n 2D matrix representing an image. Rotate the image by 90 degrees clockwise. You have to rotate the image in place, which means you have to modify the input to the matrix directly. Do not allocate another to the matrix and do the rotation. So looking at this example on the left side, we have the input and the right side is the expected output. And it looks like they are expecting us to figure out a way to get the output column wise, starting from the bottom. So if you take a look right there, we have, it's going to be 741 on the top, 852, on the second row, 963 on the third row, so on. So the second example is the same thing. The only difference is it is much larger arrays. So uh, the way I'm going to approach this algorithm is first by creating, I'm going to create uh, I'm going to be using the length of the matrix maybe three times, or maybe I don't know, whatever, but let's just create a length a variable. I'm going to set it equal to matrix dot length, right? So then I'm going to do a for loop, and I'm going to start my count at 0, and then I'm going to do I less than length, and then I'm going to increment I as I'm looping through. So then I'm going to create a countdown a countdown variable, which I'm going to set equal to the length minus 1. I'm doing it because an array always starts at the index of 0. But using the countdown, if I keep the length of the current matrix, it is going to be one more, because the length is going to give me, in this example, if I keep the length without doing minus 1 for my countdown variable, it's going to be 3. So if I use 3, I would not be able, because 3 is going 3 should be in 4 arrays, but in this case we only have 3 arrays inside our array. So doing minus 1 would give me the exact length of the current array. So then I'm going to do a second loop, and then I'm going to do the same thing, less than length, and then I'm going to increment j as I'm looping through. So then what I'm going to do, I'm going to first grab the element. So the way I can grab the element is by doing matrix. At the index of I is going to give me the first array, and then I'm going to pop the last element inside the array. And so then what I can do, I'm going to inshift the last element inside you know my the last element that I popped inside the first array. In this case, it is going to be 3. I'm going to inshift to my last array. So then uh, I can grab the last array by using the matrix at countdown. So then I'm going to use a shift method, and so then pass the element argument, and so I can decrement countdown, and so on and so on. So it's going to move from the first array to the second array and popping always the last element and then shifting to to the next array, and so on and so on. So then I can return the matrix. So let's run the code and see what we get. Okay, looks like we got the expected output. We got 741. So yeah, and now let's submit the code. Good. The code is being accepted. So now let's look. Okay, I don't trust this thing a lot. The runtime. You know, percentage from lead code. So let's go back and try to submit the code again, because sometimes if you go back and forth, you might get a higher, runtime time. So just curious. Now we're getting 87% of JavaScript submission. So just to, make sure, our current code is going to be big or square. So that's what's up. So basically, this is going to be big or, square. So thank you so much for watching this video, and see you guys next time for another algorithm solving. Thank you.